Welcome back to Boring Astronomy. Last time, we took an epic tour of our cosmic island home, the Milky Way galaxy. We marveled at its incomprehensible size, its billions of stars, and the slow, majestic spiral it performs around a quiet, supermassive black hole. We discovered that our own sun is just one unremarkable star in a vast, constantly spinning galactic city. Tonight, we're going to venture even further out, beyond the comforting embrace of our own galaxy, into the truly immense, profoundly silent, and often unsettling emptiness that is deep space. This isn't the dramatic, star-filled void of science fiction. It's the quiet, cold, and mostly empty reality that dominates the vast majority of our universe. Its sheer boringness, its lack of anything to see or hear, makes it one of the most compelling aspects of cosmic reality. So, dim the lights, perhaps turn on a fan for that soft hum, and let's ease into tonight's journey together. When we talk about deep space, we're not just talking about the space between Earth and the Moon, or even between our sun and its nearest star. We're talking about the vast, nearly absolute vacuum that exists between galaxies, the unimaginably immense stretches of nothingness that separate one cosmic island from another. It's the ultimate quiet. There's no air, no sound, no friction, nothing to interact with, just emptiness. This isn't a chaotic, swirling maelstrom. It's an enduring, profound stillness that defines the majority of the universe's volume. Think about the distances. Our nearest large galactic neighbor is the Andromeda Galaxy. It's on a collision course with the Milky Way. But don't worry, the actual collision won't happen for another 4.5 billion years. A timeline so vast, it makes human history feel like a fleeting blink. What the boring fact is that Andromeda is roughly 2.5 million light years away from us. That means the light we see from Andromeda tonight left that galaxy 2.5 million years ago, around the time our earliest hominid ancestors were first walking the Earth. That's 2.5 million years of light traveling through almost complete nothingness to reach your eyes. This distance isn't dramatic. It's just a silent, unfathomable expanse, patiently waiting for light to traverse it. In deep space, there's no atmosphere to scatter light, no dust motes to shimmer. This means the sky is perpetually black, even if there are billions of stars around. On Earth, our atmosphere scatters sunlight, making the sky blue during the day and providing a luminous background at night. In deep space, without an atmosphere, the sun would be a blinding point of light, but the rest of the sky would be utterly dark, speckled with sharp, unblinking stars, like diamonds on black velvet. There's no light pollution from nebulous or glowing gas clouds, just the pinpricks of distant suns, unwavering and cold. And the temperature is not just cold, it's profoundly cold. While objects exposed to direct sunlight in space can get very hot, the ambient temperature of deep space, far from any stars or planets, is incredibly close to absolute zero, about 2.7 Kelvin. This is the cosmic microwave background radiation, the faint echo of the Big Bang itself, omnipresent and uniform. This isn't a chilling wind, it's the ultimate pervasive chill, a state of near-perfect thermal equilibrium. That means there's almost no heat to transfer, no warmth to dissipate. It's the boring, inescapable temperature of the universe's background hum. Perhaps the most striking aspect of deep space is its silence. In movies, spaceships make noise, explosions boom, and lasers zap. In reality, space is a vacuum. Sound waves require a medium to travel through, and in the near-perfect vacuum of deep space, there's virtually nothing. Explosion right next to you would be utterly silent. A scream would be unheard. This profound quiet is not just boring, it's deeply unsettling to our human senses, which are so reliant on auditory input. It's the sound of nothingness, the ultimate void of noise. It's a constant reminder of our own planet's unique sonic environment. Even though it seems empty, deep space isn't entirely devoid of matter. It's filled with an incredibly tenuous distribution of hydrogen and helium atoms, cosmic rays, magnetic fields, and of course, dark matter and dark energy, which we'll delve into in a future episode. But these components are so incredibly sparse that they exert almost no influence on anything traveling through them, making them effectively nothing for all practical purposes. It's like finding one grain of sand in an ocean, technically there, but irrelevant to the vastness. The sheer scale of deep space also means that collisions between large celestial bodies are incredibly rare. While galaxies do eventually collide, as we mentioned with Andromeda and the Milky Way, these events unfold over billions of years, and even then, the individual stars usually don't hit each other. The space between stars within a galaxy is vast, and the space between galaxies is infinitely more so. It's a traffic pattern where collisions are so infrequent, so slow, that they become almost statistically insignificant on a human timescale. This is the boring safety of cosmic emptiness. Deep space is also home to cosmic voids, colossal regions spanning hundreds of millions of light years that are almost completely empty of galaxies, clusters, and even individual stars. These aren't just empty pockets, they are gargantuan bubbles in the cosmic web, vast, silent expanses of nothingness that truly underscore the boring nature of interstellar and intergalactic travel. They represent the ultimate cosmic quiet zones, where even the faint echoes of the Big Bang are the loudest thing around. Next time on Boring Astronomy, we'll come a bit closer to home and embark on a detailed tour of our own solar system. We'll explore the boringly diverse planets and other celestial bodies that orbit our sun, each with its own quiet characteristics and predictable motions.